Okay, this is question 2 from January 2007. It's a question about the gas laws, and in particular this is Charles law. Now this isn't on the new specification, but I still think that it's reasonable to be able to answer questions about what you should be doing. Here's the apparatus. We've got a bead of sulfuric acid trapped inside a capillary tube, so therefore the bead of sulfuric acid traps air, so we've got fixed mass of air acting as the gas, and what we're going to do is we're going to heat the water and see how the volume responds. So we're asked to describe how the apparatus would be used to investigate the relationship. So very simply, we heat the water. Okay, so we heat the water bath over a wide range of temperatures. Stirring as we go along to ensure the temperature is even throughout. Record the temperature and length of air column. At regular intervals. Okay. So then we have in the capillary tube, it has an internal diameter of 0.6 knot millimeters. During heating, the thread of concentrated sugar moves from a height of 20 to a height of 22. The initial temperature of the air was 18. Calculate the new temperature given your answer in degrees Celsius. Alright, so we're very simply going to say here, well, the pressure in this is constant, so we can say V1 over T1 is equal to V2 over T2. Therefore, we have the initial temperature was equal to 18, so that becomes 273 plus 18 becomes 291 over, and that then becomes 20 is equal to, we don't have to multiply by the diameter all the time because it stays the same, so it would go out on both sides, so that's equal to 22 divided by the new temperature T2, so that means that T2 is equal to, and that becomes then, if we rearrange that, that's T2 is equal to 22 times 291 over 20, and that gives a value of, put that into your calculator, so we've got it comes out at 320 Kelvin, therefore in degrees Celsius, so it's 320 minus 273, and that's equal to 47 degrees Celsius. So 47 degrees Celsius. Label the axes and include appropriate units. So this is the graph, temperature, volume was plotted, but we need to be very careful here because temperature would be proportional to the absolute temperature, but this is, sorry, volume would be proportional to the absolute temperature. So this is the volume, right, and that's in millimeters squared, and this is the temperature, and that's in degrees Celsius. And it's just important, this is degrees Celsius, and this is an appropriate unit, which would be millimeters squared in that case.